for the University of Texas Energy Symposium for November 11th, 2025. I'm Kerry King, Research Scientist and Assistant Director here at the University of Texas at Austin. And before I introduce today's speaker, I will point out the next talk, which is the last talk of the fall 2025 semester. This will be by our own Andrew Fix, who is Assistant Professor in the Department of Civil, Architectural, and Environmental Engineering, and he'll talk about moisture matters, leveraging water vapor selective membranes in the built environment. That'll be our last talk for 2025, and the next talk will be in January 20th, 2026. But today is a pleasure to have a colleague and friend, Chris Kennedy, who's professor at the University of Victoria in British Columbia, Canada, and he is part of the Institute for Integrated Energy Systems. A little bit of background on Chris. As I said, he's a professor at University of Victoria. He's worked for over 30 years in the world's toughest environment and sustainability challenges, from climate change, waste, and pollution to declining biodiversity. He's been a consultant to several national governments and international institutions, including secondment to the OECD and Paris. He was previously professor at University of Toronto, visiting professor at Oxford University and ETH Zurich. He's a fellow of the Canadian Academy of Engineering and a former president of the International Society for Industrial Ecology. He's published and authored 3 books that will inform his talk today. The last being the Malthus Enigma. Well, maybe the last one is Advanced Introduction to Industrial Ecology, but the last one for the sort of lay person is Malthus Enigma, Technology, Science, and Policy for a Fragile Earth. The talk today will talk about 3 major United States macroeconomic policy paradigms within the 20th century, defined by transformational economic shocks, that these had distinct energy characteristics. There's the pre-Keynesian era up to 1929, dominated by coal. There's the Keynesian era, 1930 to 73, witnessed substantial growth with unconstrained access to abundant domestic oil. And then the Monetarist era, after 1973, in which he will discuss was energy constrained. Moreover, the economic shock that precipitated these paradigm changes were rooted in changes to energy supply. The Great Crash of 1929 followed discovery of vast oil fields in the United States Southwest, and the collapse of the Bretton Woods system in 1971 occurred part due to U.S. peak conventional oil production, and together they established the conditions for the first oil crisis in 1973. So with that said, I welcome Chris Kennedy and stop sharing my screen and let him continue. As always, please ask your questions in the question and answer feature of Zoom. If it's a clarification question, I'll try to interject during his talk. Otherwise, I will ask at the end. With that said, Chris, take it away.
So you can see my screen okay?
I see it fine. Thank you.
Excellent. Thank you for the introduction. It was great. You went through the abstract there. I'm going to be pretty true to that abstract. I have to first of all recognize I gave this presentation to a group in Stockholm, Sweden, where I'm currently located for this week. This is much more risky for me because I'm the Canadian telling the Americans about about American history, especially energy related, to a group of people, most of whom are in Texas, who know about energy. But hopefully this will be of interest to you. Let me just go and say a little bit more about that book, the one the one of the 3 you referred to, the Malthus Enigma, because it was in writing this book that I discovered the material I'm about to present to you today. Not a lot of it is actually in the book, but I learned about it through this process. It took me about 10 years to write this book. It's kind of a 250 years view of sustainability, of humans trying to live sustainably on the planet, covering everything from systems and science of sustainability through to ecological economics and industrial ecology. It's important for you to recognize this because it shows where I'm coming from, because a lot of what I'm going to talk about today is really about fossil fuels, which isn't necessarily a very sustainable thing. But I think there's a good starting point for the presentation is sort of this. There's a grassroots movement, a popular movement that go around saying that we need system change rather than climate change. Protesters take this these placards like you see the one here out. And I think there's something quite actually profound and deep about what this says, because we know we need to transition to a net zero carbon energy system, and that's pretty clear because of greenhouse gas emissions. But what's less understood, and I'm going to show you today, is that major past energy transitions have also entailed really fundamental changes in economic systems. And we're going to see that through this case of the United States economy in the 20th century. So my objective in the presentation is to demonstrate, to show, this is a hypothesis, I'll give you some proof to back it up, that these two major paradigm changes occurred due to changes in energy supply. In one case, it was discovery of massive oil. In another case, it was sort of peaking of oil, conventional oil, that is. In terms of the contents of my presentation, I'm going to do a little bit of sort of introduction and framing the scene. I'll then go into the 1970s oil crisis. I don't think I'll do anything too remarkable in that session, and people might bicker with the way I interpret the oil crisis. But the third part, interpreting the Great Depression as being an energy transition, is pretty new and pretty radical. And if there's any economists listening in, could be somewhat shocked by my approach. But let's give it a shot. So let's go into the framing first. And first of all, I want to recognize a couple of challenges. The first one is that there really is no macroeconomic theory of energy transitions. So it's not like I can pull up an existing law or existing equations and show, here's some new data, and let's just apply this theory, and now we can see that the energy transition had these economic effects. Because largely macroeconomics and energy don't meet very often. They do meet sometimes, but there's a whole discipline of energy economics, but it's really a microeconomic discipline, and it doesn't really capture macroeconomic effects very well. The second challenge is, even within the energy transitions literature, I think there's major important details that have been missed. And let me just sort of give you an example of that second challenge straight away. Here you can see primary energy supply for the United States up to 1970. I cut it off at 1970 because I wanted to sort of home in on a couple of places. I'm not sure whether you can see my mouse or not, but most of the energy transitions literature would really focus in on the point where oil and natural gas went past coal and say, hey, that's where the transition is really taking place. And so a lot of the literature, whether it's talking about Western Europe or talking the United States, they tend to talk about the 1950s as where oil and natural gas went past coal. But that's only like the sort of a part of a transition. And for me, the interesting part of the transition is kind of where it starts. And so then you start going back to 1920 and say, well, wait, coal kind of reached a peak in 1920 and then was flat for a while. And this is the era where petroleum and natural gas were accelerating and catching up to coal. So I think there's actually more to be learned there than in the 1950s. And I'll get to that one later. Now, on the lack of a theory, a macroeconomic theory of energy transitions, I've done a little bit of work in this space. This is by no means a full theory that I'm showing on this screen, but in previous work, actually looking at the Industrial Revolution, I think that the three key components to building such a theory would recognize that you need energy to build capital assets, and then you need energy to use capital assets once you've constructed them, and the capital assets themselves are needed, as well as energy, in the production of energy. So there's some important feedback loops in such a series of energy transitions if it was ever to develop. And I also want to give a nod to Kerry on this, because although I'm not sure it's quite as explicitly written, but this is also in the Harmony model as well, with a bunch of other things. So this is something where Kerry and I have a common line of research. I'm going to come back to these three bullets much later on in my presentation, but I did want to kind of get that out in terms of preparatory material. But let me dive in now. So the main framing for this paper and the paper's called Energy Constraints on Economic Paradigms, and it was published in Ecological Economics. The main framing has a number of influences, and the first one is John Stuart Mill, who's this English economist, sort of social leaning economist, who in the preface to his book on political economy said that the production of wealth is primarily dependent on the physical properties of matter and also human knowledge of those properties. And Mill really considered the role of political economy, or if you like, macroeconomics, really just to deal with distributional aspects. Mill heavily influenced the field of ecological economics. So people like Daly and George Esca-Rejan referred to him. Cleveland and Ayres, also in the ecological economic literature, have put energy into sort of production functions for economies. As my paper spans between ecological economics and macroeconomics, I also refer to some macroeconomic literature because we're going to be talking about changes in economic regimes. So there's when talking about the US economy or other economies, when there was this emergence of a Keynesian economy and then the monetarist economy, macroeconomists have written about how those changes occurred and what went on. And amongst those people that have written about that, there's one important influence on my work, which is a book by Mark Blythe. So I think he's based on the East Coast US. And he has a book called Great Transformations, Economic Ideas and Institutional Change in the 20th Century. And he basically examines the rise of Keynesianism from the 1930s and then monetarism from the 1970s. And he recognizes that there are shocks to the economy. The economy is in crisis. Sorry, excuse me. And then there's new relationships have to be worked out between the state, organized labor, and organized business. And his book then basically describes how these new economies evolve and how there's ideas about economics in them. I essentially took Mark Blythe's two changes in economic paradigms or economic regimes, and then overlaid changes in energy consumption in the United States. So on this graph, which is kind of the centerpiece of the paper, which I kind of lay out my broad theory, has a primary energy consumption on the y-axis in gigajoules per person. So it's and you could do it in total energy use, but it's neat in terms of per capita. And then on the x-axis, we've got the whole of the 20th century. I'm not going to go into 21st century. We can talk about that in questions if you want to. And then I've got the obviously the types of energy use. I'm not going to get into useful energy. I'll just keep it in straightforward energy. No exergy in here. But you can see that the red vertical lines are where these shocks occur. And after an economic shock, there's a transition period where sort of everyone's trying to work out what the new rules are and things are being renegotiated. And obviously, the first of these is the 1930s, and then the next one of these is the 1970s or after 73. And as Kerry nicely summarized in the abstract, you can see that the first period, I've called it pre-Keynesian, some could call it neoclassical, but it's the period before the Keynesian is what I'm getting at. It's up to 1929. It's the economy, the US economy is totally dominated by coal. 1920, it was about only 10% of petroleum. At that point, it was 75% coal. And then in the next era, the Keynesian era, you've got this, and also I should say, we're up to about 200 gigajoules per capita, a little bit higher during the First World War. Then the next era begins, with the Great Crash, 1929, and then there's a rapid growth in energy consumption per capita. We go up to 370-ish, 375-ish gigajoules per capita, but all of that growth in energy use is all oil and natural gas. It's the coal rises during the Second World War, but it shrinks back down again. Then we have the oil crisis occurs and coal rebounds a little bit, not a huge amount, but coal increases, and we have nuclear taking off from this point. But notably, energy use per capita has peaked. It doesn't, or at least it's flatlined. So now, it's what I've just given you is just sort of a visual description of what you see. So there's nothing too contentious about that. Where my work becomes more contentious is I'm actually saying, well, these economic shocks were actually driven by these changes to energy system. It wasn't the other way around. That's where this becomes a bit bolder. And one thing I want to say is this Keynesian era was this rapid growth. The 3 decades with the greatest economic growth in the 20th century also all occurred during this Keynesian era. So this was this has been sort of called the golden age of capitalism. It's an era where people say, well, why don't we go back to that again? Can't we get the golden age in capitalism back with Keynesian policies? Uh, uh, but one thing I think is important to realize about that Keynesian era as we now transition and start talking to the oil crisis, and I'm going to build up to it, is that I'm not sure that you can actually point to the economic policies that were happening in the 1940s, 50s, and 60s and say that they were the thing that were responsible for that rapid economic growth. And I think a much more overarching explanation for why the US economy was so massively powerful then was the fact that the US had over 60% of global crude oil production back at the beginning of that period. So you can see here in the 1945, it's at 65%. And then by 1955, it's still, in 1950, it's still at 50%. And you can see that it wasn't until into the 1970s that the Soviet Union went past the US in terms of oil production. And that was after the US had hit peak conventional oil. And then you can see other countries such as Saudi Arabia and Venezuela and Iran rising, and the US share coming down. But US was really a global oil superpower alone for a long period of time there, to the point that US was able to dictate the price of oil to the planet. And that was what it gave it such a strong economy. Now, there's a couple of points on this graph, which on this figure, which are particularly interesting. I've already mentioned the peak oil, peak conventional oil, which a lot of people have written about. I'm not sure I'm going to say anything new about it, but we'll see. But there's also a peak occurs here in the Soviet Union's oil production, which is 3 years before the collapse of the Soviet Union. And what's really interesting is that there's a paper by a couple of economics professors, one of them's based in Alaska, who actually did Granger causality tests and came to the conclusion that the reason why the GDP declined in the Soviet Union was because they peaked in their oil production, and essentially said, hey, you could actually blame the breakdown of the Soviet Union to them peaking in oil. Now, the US didn't break down, ceased to be a state, a group of states, I should say, when you guys had peak oil. But the US certainly went through a major change in 1974 when the first oil crisis hits, and that again is also 3 or 4 years after peak oil was experienced in November 1970. Now, in the paper, we make some arguments showing that you can relate the first oil crisis back to peak oil, and you can also say that there could be a relationship between peak oil and the end of the Bretton Woods system. So, just as a reminder here, up to August 1971. Other currencies, Western currencies, not all countries in the world, but the major trading allies in the world of the US, had their currencies pegged against the US dollar. It was a quasi-gold standard, but it was basically a US dollar standard. And most of the role of the central banks was just to basically maintain those exchange rates. But what happened was, even though the US didn't actually know it had peaked in oil, because it's not a dramatic, there's a bit of erratism to it, and it's not a sharp peak, it's a gradual. But 9 months after it, you had Nixon, who went away and came back and said, we're going to end Bretton Woods. And there was also a freezing of wages and prices for a number of months, as well as the US was about to go into a recession. But essentially, the Bretton Woods system ended because the U.S. was no longer in a trade surplus, and I don't think you can maintain. Not just it was recognized by the policy folks in the White House that they couldn't maintain the Bretton Woods system when the U.S. went into a deficit. There's other factors involved. in the end of Bretton Woods. There's also something called the Vietnam War going on. There was a bit of inflation, although that has some relation back to oil as well. But whether you accept the end of Bretton Woods in relation to peak oil, there is a connection between peak oil and first oil crisis, which is really more of a story. You can't necessarily put data to it, but there's work by Hall, which I've referenced him here. Oh, sorry, not Hall, Hamilton, 1985. I've added a few numbers to his analysis, but basically what he shows is that before the US experienced peak oil, that whenever there was a major event in the Middle East, the US typically stepped in, and the US actually, in this case, most of the case, it meant the Texas Railroad Commission, because that was controlling most of the US oil supply, stepped in and increased the supply of oil when US policy and the stability of the Bretton Woods system was under threat. So 1951, Iran nationalizes its oil supply. US leads a boycott of Iranian oil and increases its production to manage the supply shock. The Suez Crisis, 1956, US wasn't affected very much by it, but that year, US supply went up by 274,000 barrels per day over the whole of the year. Similarly, not even 1967, so only 3 years before peak oil, Texas Railroad Commission increased supply by 700,000 barrels per day. Then we have the Yom Kippur War and January 1974, there's this massive increase for the factor of 7 or something like that in oil supply, in the price of oil. And the US had lost its ability to control the price of oil. And that year, US supply declines by 479,000 barrels per day, because basically it didn't have the mechanism of increasing supply available anymore because it had physically peaked. So when you translate this into economic terms and economic regimes, using oil prices as the y-axis here, the Keynesian era and the monetarist era are starkly different. The Keynesian era is basically an almost constant oil price. It gradually goes up a little bit. The monetarist era is full of rapidly changing oil prices, which then have perturbates through the economy. So in the Keynesian era, your central bank or your central reserve is mainly concerned with just maintaining exchange rates with international partners, whereas in the monetarist era, it's mainly about controlling inflation. No, there's inflation needs to be controlled in both, and the shocks that can occur, not necessarily oil-related shocks can occur, but the fundamental central role of the central bank changed with this change in energy regime. So I guess whether you like all the details the way I described it there, at least we're on fairly safe ground to say that change in economic paradigm that occurred around about 1973 was clearly related to the oil crisis. Where this talk becomes more adventurous, you have to excuse me for taking a glass of water here, is if we now go and talk about the first of those major changes in regimes, which was when we talk about the Great Depression. Because people don't recognize the Great Depression to be an energy transition. But a starting point on this is, and this repeats some of what we've just said, but it actually it takes it from what is actually a classic paper in economics. If there's any econometricians or macroeconomists in the room or listening in, they might be familiar with this paper. It's been cited about 10,000 times or more. It's a paper by a guy called Pierre Perron from 1989. What Perron did was he collected a whole bunch of economic data up to when he published in 89, it's mainly 20th century, it goes a little bit further back. And he recognized that there were 2 points at which there was a major change in the economic patterns. So, looking at the time series, there was non-stationarity, or technically there was a unit root occurred twice. One of them was 1973, the other one was 1929. So this corresponds with our 2 points that we've already recognized. And it's important to realize that the change, the shock in 1929 was initially a rapid decline in the economy. Sorry, it was a shock downwards in the economy, followed by a periods of exceptional growth. And I'm going to argue that was when you transition from coal to oil. Now, the first thing to say here is, well, I haven't read all of the 10,000 papers that cited Perron, but it was clear that his work was recognized for its mathematical skill and its contribution to statistics. And I don't think anyone really reflected on what was the big picture here. The paper was called The Great Crash, the Oil Price Shock, and the Unit Root Hypothesis. But if the second one of these shocks or unit roots is clearly oil related, it's reasonable to say, well, couldn't the first one of the shocks also be oil related? Doesn't necessarily follow that it should be, but it does mean that looking at an energy shock would be a good idea, a good avenue to explore. So that's what we're going to do here. Now, of course, I've got to recognize that there's 95 years of literature and economics of people trying to understand the Great Depression. Ben Bernanke called it the holy grail of macroeconomics. And I do have some slides which I'm not going to show of sort of Monty Python and a whole bunch of economists trying to work out how the Great Depression occurred. So there's explanations that talk about monetary theory. There was a small modification of interest rates in 2 years before the crash. There's people who've looked at it from sort of Keynesian perspective. It was a lack of consumers lost confidence. There was the trade dimensions, although we shouldn't really mention trade dimensions these days because trade tariffs are back in, aren't they? But a lot of people pointed to the tariffs during the Great Depression as a cause of the depression. I'm not. I'm going to say some of these might have applied, but I think I've got a more comprehensive, overarching theory of how the Great Depression occurred, and it all comes down to energy transition. Now, I was asking Kerry before we started this presentation how much you guys learn about the Depression in high school, and so I'm assuming maybe not much these days. I don't know, but let me pull out five key aspects of the Depression. First of all, there was a Wall Street bubble in roughly 1927 to 1929. It was actually a technology bubble, as I'll show you. I'll show you later, similar to the dot-com bubble at the end of last century. The Depression had a period of massive deflation, so prices went down. That deflationary period actually started just before the Great Crash. The Great Crash is October 1929, where the stock market collapses drastically over a week. The Depression itself, between 1929 and 1933, there was a 50% decline in industrial production and unemployment of 25% or more. The numbers are not exact, but they're rough. And at the sort of the worst part of the Depression, which was pretty much March 1933, Roosevelt comes in, and the first thing he has to do as president is basically close down all of the U.S. banks for over a week. Work out, not him personally, work out which ones are still solvent, and then when they reopened the banks, there was several thousand that didn't get reopened. So it was a major bank failures was really kind of the low point of the Depression. I'm going to use these five aspects. I'm going to come back to them, not exactly in this order, but we're going to come back to them in this presentation. So, but to really understand why the Great Depression can be seen as an energy transition, it's important to first understand what was going on in the 1920s in the US. In the 1920s, oil was considered to be scarce. I've already said that it was only about 10% of energy supply in 1920, but it was rapidly being increased because of motor vehicles. And it had been realized that oil was important for industry as well, and obviously for military. But in the 1920s, early 20s, the U.S. Geological Survey came up with reports saying that America's only got about 15 years of supply, and that 15 years was based on current rates of consumption, and consumption was going up. There was such a concern that President Coolidge formed a federal oil conservation board, and their task was eventually to use petroleum more effectively because they were worried about running out. There's an interesting confrontation then, because the American Petroleum Institute responded by saying, we think there's 1 billion acres of land with great geological promise for oil. And they turned out to be right, of course. You guys in Texas know all about that. But at the time, they hadn't found the oil. So seismology was only first used in Texas and Mexico around about that time. And so Coolidge has this very contradictory statement in the middle of in his introduction to this Conservation Board report, saying oil of which our resources are limited is largely taking the place of coal. And of course, if something's limited, it's difficult for it to take the place of coal. Even as late as 1928, when the second report of the excuse me, the Federal Oil Conservation Board came out, it basically said, don't worry if we run out of conventional oil, because we can grow crops, we can get shale oil, or we can make oil from coal. These were ideas, some of which were pursued in some parts of the world over the following decades. But 1929, everything changed. This quote from 2015 summarizes a couple of really important things. First of all, he says in October 1929, U.S. commercial crude stocks peaked at 545 million barrels. And this is a really, really important detail. It could be subtly missed. The petroleum companies in the 1920s were storing oil and these large stores of oil because they were worried about running out, and they wanted to hedge against at least price shocks. But then there was massive discoveries of new oil fields in Oklahoma, Texas, the rest of the Southwest, in California. And then this is where things get really kind of interesting, and something that's probably been forgotten completely from history occurs, because I want to take you to a couple of headlines from the New York Times. The first one is October the 22nd, 1929, and the second one is 1 week later on Tuesday, October the 29th, 1929. And the first one, they're both about Standard Oil, and Standard Oil has been split up into its different parts at this point. The first one is talking about Standard Oil of California, and they dug these deeper wells in California in 1929 and hit a whole bunch of new oil. And there's big overproduction occurring. So Standard Oil of California reduces the cost of oil there by 50 to 75 cents a barrel, which doesn't sound like a lot today, but it was an average of a 55% cut in the price of oil, which is a lot. That's a big cut. The Shell Oil Company of San Francisco followed suit. And then the next day, which was October 23rd, there's a very small article saying that Union Oil of Texas, operating in the California market, also would follow the cut. The day after that was October 24th, which is the first day of the Great Crash. And I think, and you probably haven't seen enough evidence yet, but I actually think that the trigger for the Great Crash was probably this oil price cut in California. Now, the crash was going to happen anyway because it was a technology bubble, but I think that this oil price cut was a possible explanation for why the crash occurred. And it could just be a coincidence, but the thing is, there's another coincidence that we have to talk about on October the 29th. The Great Crash occurred over a period of about a week. Banks stepped in. There was tried to boost the market up again. Monday wasn't a very good, on Monday the 28th wasn't a good day for the market. But October the 29th is known as Black Tuesday. It was pretty much the worst day in the 20th century for the New York Stock Exchange. And there's another article in the New York Times, and this time it's about Standard Oil of New Jersey, which was the original Standard Oil and the biggest Standard Oil. And they made this announcement. They've reversed their previous policy of storing crude oil. They stopped doing it. And what's really quite surprising about the headline there, if you look at the very bottom caption, it says, "Future held no longer uncertain," which is a very strange thing to write. The future is held no longer uncertain. And if you dive in and you look closer at that, and let's look at the first line of the article itself. It says, the New York Times on Black Tuesday has an article that says, holding that the future supply of crude oil was no longer an uncertainty, Standard Oil in New Jersey yesterday, so this is just coming out, announced the reverse of a long-established policy of storage of crude oil against a possible shortage. And it took me a while to work out and understand what this really meant. And what it really means is it means welcome to the oil age. It means that the oil age is here. We have this 1920s uncertainties has gone. And it's difficult to show this through stock market data, but I've got one approach of seeing it. Here's some stock market price indices from Cal's index for oil producing and refining companies shown in red, and coal companies shown in black. And the dashed line is just the overall stock market. everything is normalized to 100 in 1926. That's the way that Cowles did it. So I've not done anything to the data. I'm just reproducing the data that they had. And you can see that the oil companies, pretty much the stock price went up with stocks in general, not quite as high, but it went up with the market and it fell with the market and pretty much matched the market. So that by 1936, the stock price index for oil producing companies was pretty much the same as what it was in 1926. So no big change there. Obviously, well, there was a shock, but a recovery. Whereas with the coal companies, they didn't go up with the bubble. They were pretty flat, dropped like a stone, and then dropped by 85, 90%, and barely recovered at all. There might have been a bit of recovery when we get to the Second World War, when coal sort of came back a bit. But basically, what you're looking at is like a transition curve. I think my interpretation of this is that the Great Crash should be seen as a tipping point from a coal age to an oil age. And I've got a few more graphs and data that can support this idea. So let's actually look at the use of energy in the US for ground transportation. So this is trains and automobiles and trucks, etc., combined, just ground transportation. You can see that in 1931, petroleum surpassed coal. Maybe I'm guilty of focusing on the point where they pass. I warn that you shouldn't do this when you look at transitions, but from a transportation perspective, the important energy transition, I think, is this one in 1931, not the one later in the 1950s. And if you want to really understand how this all came about from an economic perspective, then we need to go back and look at what was going on in the 1920s in terms of investment. And so this graph, it's a little busy, but it's got a tremendous amount of important information. So I'll spend a bit of time on it. You can see, so this is investments in, it's actually straight out of US Census Bureau statistical abstracts. It's a standard table that they used to do every 2 years. Has water turbines in it as well, but I've missed them out because they were relatively small. And it just shows millions of dollars of investment. And you can see that in the early 1920s, especially 1923 here, you've got large investment in steam locomotives. We're still in the coal age, and the US is investing in steam trains. By 1929 or 1927, if you like, that's fallen so that there's more investment in motor vehicles and other internal combustion engines. And so that you can see that the decline in coal investments in coal technology has already started. But there's obviously people know the story of motor vehicles and Ford and motor vehicles very well, but there's a couple of other really interesting things going that's shown on this graph. One of them is that we've got this rapid increase in investment in tractors, really going up, so it's really high in 1929. And there's also the first appearance of aircraft in the data, starting from 1927. And we should talk a little bit more about what's going on with these two technologies, because tractors went through a period of massive growth in productivity and efficiency between 1922 and 1930. There's a PhD thesis by White out of Ohio State University that shows that the threshold for tractors to compete with horses went down by 3 orders of magnitude in almost 7 years. You may take the square root of that because it's an aerial term, but you had Ford come out with a cheap, expensive tractor. International Harvester followed. John Deere added a power lift. You got the first combine harvesters, you got corn pickers, and even just adding rubber tires increased efficiencies by 30%. So tractors, obviously petroleum-based, it had a major effect on US agricultural system in the 1920s. And then when we turn to aviation, I don't know whether Americans remember Charles Lindbergh anymore, but he, in the first half of the century, he was kind of like Neil Armstrong and Elvis combined all into one guy. He was obviously a Swedish heritage, but he was the grandson of a Swede. He was a flying planes airmail, and he competed in the Ortega prize to fly from New York to Paris, and he won it. Complete unexpected winner of this prize. He did it by flying 35 hours straight in a single engine plane, which was basically a fuel tank with wings. He was an absolute hero, and he became a superstar. And then he spent the next couple of years, backed by the US Department of Commerce and the Guggenheim Foundation, basically growing the aviation industry in the US. He visited 40 states in like 4 months or something like that. No, sorry, he visited 50 states in 4 months. And so there was a massive investment into the aviation industry, which was known as the Lindbergh boom. So if we go back now and talk about, well, let's look at that Wall Street bubble and ask, well, what technologies were actually behind that Wall Street bubble? And we go to Cowles indexes again. We see that airplanes actually were the technology sector which actually peaked the most. You can see the dashed blue line at the bottom there, which has the overall stock market going up to 250 relative to 100 again in 1926. But airplanes, that's both manufacturers and commercial airline companies, which are all pretty much brand new, their stock prices went over by a factor of 10 or more. Next down after that, you've got radio, phonography, and musical instruments. Probably wasn't the musical instruments, it was the radio that went up. And then you've got agricultural machinery, again, petroleum-based, and you've got the utilities, which is at least energy-related. So you can point to petroleum technologies as being a big part of the technology bubble that people call that was the Wall Street bubble. I think I've only got 15 minutes left, so I might have to skip some of the slides, but
We got about 15 minutes, or see if you can get to questions in 5 minutes or so.
Okay. Let me skip through that. Let me skip through a couple of slides then. Basically, I did some statistical analysis that showed, using greater causality tests, that you can explain the deflation that occurred in the US in terms of 89% of it can be explained by farm prices and petroleum prices together, which and the farm technology obviously is the arrival of the tractor. And the same statistical tests, we observed that while farm product prices and petroleum product prices went down in real terms, bituminous coal, iron and steel, and building materials went up in real terms. In other words, the ingredients for capital formation went up. It became more expensive relative in real terms, and which is part of the reason why construction completely went down in the 1930s. And I'm going to skip this one. The most incredible statistical result that was derived in this work was that I found that real coal prices could explain the changes in money supply, household income, and industrial production. So the major statistical result, which sort of means that you can associate the changes in the economy with the energy regime, with coal prices. The railroads, we haven't spoken about them much, but this quote from Olson, who was writing about the sort of the New Deal economics, he notes that the railroad crisis transcended the Great Depression. So the railroads weren't just an industry that suffered because of the Depression, but actually the failure of the railroads was something that was transcending. It was greater, overarching the Great Depression. I applied some of my fancy capital energy analysis, which I'm not going to go into here, but railroads was in it. So this is back to my relationship between capital and energy. I'm going to skip the slide, but here's the really big important takeaways, which can give you a sense of why there was such a collapse in the economy after the crash in 1929. The railroads in the US were massive. They had about a quarter of the non-residential capital stock. It's just like a quarter of the assets in the US economy, not including housing, is all in one industry. It's equivalent to your power industry, all your roads, and all your other transportation industry in the US today. So it's very, very powerful. And not only were the railroads the transportation system, the main transportation system in the US, they were also the major energy supply system because the railroads moved the coal. So you've gone through a technology shock, oil has arrived suddenly, and you've got revolutions in both your transportation and your energy sectors at the same time. And also you needed that energy for capital formation. So you've got a fundamental change in your underlying architecture structure of the whole of the economy as railroads are being outcompeted by your automobiles, your trucks, and your buses. And then when we come to the question of why did banks decline, it turned out that about a year after the great crash, which is the stock market crash, there was a bond market crash, and that bond market crash was led by second grade rails. This is not published data, this is not published paper yet, but we've done the statistical analysis of this, and we can show statistically that basically the railroads were what caused the banks to fail because railroads were so established and so part of the financial architecture of the country that banks were investing in them, and when they invested without the appropriate diversity, that's when the bank got caught up when this massive bond crash occurred. So let me just do a bit of a summary then. We've seen that the Wall Street bubble was led by aviation, agriculture, machinery, utilities, and other stocks. That's all oil related. We've got deflation that was caused by declines in farm product prices related to tractors and petroleum prices. The Great Crash, I think, I've shown you the headlines. I think you can point to oil discovery. I think it's a tipping point. The collapse in industrial production can be explained in terms of real coal price, the rising real coal prices. I think that's a statistical result that might be a better model to be worked out yet. And the cause of bank failures was the collapse in railroad bonds. So basically, the US went through an energy transition. It's a revolution in agriculture, fundamental changes in transportation systems and energy supply, and a substantial reconfiguration of the stock of capital assets in the economy. Basically, and this is summarizing it in one really sweet sentence, basically somehow economics missed the change in civilization. That is what I'm a big point of what I'm saying here. At the end of the day, it was really about technology. It was a response to a fundamental change. It was a change in socio-technological regime that caused the Great Depression. So just a few closing thoughts. There's like 3 slides left, and then that leave us a good 5 to 10 minutes on questions. I'm going to start with a quote from Keynes. Maynard Keynes, obviously, the Keynesian era was named after him. And this, I don't want to take anything away from him. Back in 1930, when the first year of the Great Slump, as he called it then, he says, "We have involved ourselves in a colossal muddle, having blundered in the control of a delicate machine, the workings of which we do not understand." There's an irony in here because machines run on energy, and I guess he certainly didn't understand that the economy ran on energy at that point. And it's questionable whether actually the US understanding of what went on is any better to that quote from Keynes in 1930. Another quote by Huber, who's kind of writing about the history of the oil industry in the US, has a very profound quote in the book called Lifeblood. He says, "In the United States, the last time the socio-spatial organization of life and energy consumption was profoundly reorganized was during the 1930s." And so he's really hit the nail on the head there. That's what happens when you've got this discovery of oil and the constraints in oil are pulled away by its discovery. You get a complete change of civilization in the US, a change in organization of life. The sprawl of the cities, the interstate highway, et cetera, all then follow. So my conclusions here, and I want to put this really carefully, I've given actually about a dozen pieces of evidence and about with 3 or 4 statistical tests, which I haven't shown all the details of, but I've got about a dozen pieces of evidence showing that the Great Depression probably was caused by an energy transition. I want to be careful, though. I don't want people to come away from this and think that that means that all energy transitions, such as the one we're trying to go through just now, should involve depressions. I think a more important takeaway would be really economics really has completely failed to understand energy transitions. If I'm broadly correct, it means that there's something bigger about energy transitions that makes them sit above macroeconomics. This is where ecological economics sits too, but even ecological economists haven't quite realized this either. So I think that's the biggest takeaway there. But if there is another takeaway, this response to the climate crisis, yeah, we really are talking about a change in civilization. So I'll stop there. Thanks. Kerry, you're muted.
Need to push more than one button. Thanks. So thank you very much, Chris. it's a few questions coming in. I'll point out at least one comment that earlier this semester, this was October 21st, we had our own Jamie Galbraith here at the LBJ School of Public Affairs, as well as Jing Chen, who is at the University of Northern British Columbia, give a talk on their book Exergy Economics, and they pointed out some similar themes as you are pointing out here in terms of thinking about energy and the economy and thinking about big transitions as you're discussing. So I could point people to that talk as well. That was October 21st. One of the comments here, I guess, is something I was thinking, but here's another comment from someone online is, how do we translate your idea to thinking about a potential next energy transition? In some sense, 1929 was a transition from, I guess, maybe a lesser quality fuel and prime mover type to a higher quality fuel and prime mover type in terms of power output. So from coal to oil and internal combustion. And in 1973, it was kind of a transition to just less of what we were used to, I suppose, and a little bit more constrained. So people differ on whether a transition to renewables or low carbon is a big boom or a big bust. So I don't know. Yeah, what do you? That's sort of the big question, I guess. If we're starts to understand energy transitions now from your work, how can we understand if one's going to occur again?
That's a good question, isn't it? I mean,
Yeah,
actually,
that's the
that's the
big
question
one.
I'm meant to be working on, and I keep getting distracted by looking back at economic history. Uh, I'll give you. I'm not gonna. I can't answer it straight on. I mean, my gut is it's the petroleum is such an energy dense fluid, right? Its properties are amazing, and so it's going to be hard. It's hard for anything to compete with it. That means that if there's going to be a change in the socio-spatial organization, it might be shrinking. But that doesn't mean economies can't grow because we're also in a new economy where 2/7 of the energy embodied there's 2/7 of the energy embodied in intellectual property products to conventional civil engineered infrastructure these days. So the nature of capital is changing to be more energy efficient. So that's a bit of an oddball to throw you. But first of all, two other things to say. First of all, people need to recognize that the 2007-2008 crash was probably also related to the massive spike in oil that happened then, and then the rapid increase in tight oil that occurred after that was sort of saved the day in a sense, or kept the convention going. I have written a paper called "Avoiding Investment in Fossil Fuel Assets," which is a pretty brave stab at what would need to happen if you really want to get off fossil fuels, you need to stop investing in the assets that support them. And the way you should do that to avoid having a terrible crash is you should have the demand for fossil fuels decline at the same rate as their assets depreciate, which is actually quite fast for oil assets because oil infrastructure depreciates quite fast because there's got a lot of maintenance required, which again, there's probably experts in the audience who know better about than me. So I should be careful what I say about that. But that's still a very partial, and that's a tiny piece of the puzzle. So I'm not going to answer boom and bust, but I would say, and maybe we kind of know this already, we're really, really dependent on energy, right?
Yeah.
It's amazing how the economists can say, blah, 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 this is what's going on in the economy, but major global wars are fought over oil,
Right.
right? Yeah.
I'm gonna read a quote here from something I'm using in a paper I'm writing, and then I'm gonna pass it to someone to make a comment. So the quote's from a 2000 paper by Robert Solow, who, for those on the group, essentially got the Nobel Prize for coming up with a economic growth model or equation that is largely used in most economic growth models today, but it's about linking technology to the economy. So it says, it would be interesting to see if any connection can be made, perhaps in a specific industry, between the time series of technological change, if you will, and an informed narrative of significant innovations and their diffusion. One can see in principle how technology should be related to product innovations, but it is not clear what would happen in practice. So I think I'm agreeing with you that, hey, if you just look at energy and changes in energy efficiency a little bit more, those are the innovations, those are the things we can count, those are the things we can see, the technologies we can see that relate to the changes in the economy. So with that said, we will try this. So we're going to pass to Jamie Galbraith. So Jamie.
Yeah, thank you. Thank you for recognizing me. It's a great presentation, and I just want to differ on the small point that when you claim that there's no economics that deals with this, because in fact one does now exist. We published it in January in a little book called Entropy Economics, The Living Basis of Value in Production. And I'll just read you a line or two that just parallels exactly the argument you were making. This is from page 125. The discovery of the giant oil fields around 1930 happened over a short period of time. The adjustment was very sudden and painful. The Great Depression was therefore unavoidable, regardless of government policies. It could be and was eventually mitigated by policies aimed at harnessing hydropower and building roads and airfields. But these measures did not immediately replace the activity lost due to the rise of oil or the decline of coal. So essentially, we're on exactly the same track, and I'm delighted to see the detailed work that you've done documenting this, the effects from particular transitions over the course of the crash and the depression. I also would just want to say that your use of Keynes in 1930 is very on point, and what Keynes said next was that nothing will avail except nothing is required and nothing will avail except a little clear thinking, which has always been something that I think the economics profession could use.
Thanks. Any comment on that or response, Chris?
Oh, no, that's just totally fabulous. I'm so happy, James, to know that there's other people who are thinking along the same lines, and that gives me a lot of hope for economists. I am partly trained in economics. You probably picked up on that, but I'm also a bit of a charlatan as well. So, but yeah, no, I'm going to dive in and have a look at your book pretty soon. As soon as I'm back from Sweden, that sounds great. And there's a couple of I went over it fairly fast, but there's a couple of published papers, actually 3 published papers, where I've got my story of the Great Depression related to energy has evolved, and they're all out in the last 2-3 years. So, but I look forward to chatting to you at some point, James.
Okay, here's another question from the audience, maybe similar to the grand. How do we know if a transition is going to occur? But will the next energy transition be driven by other leaders, say other countries? Is it constrained by technology, geology, something else? And how does that potentially impact the West's role in leading this transition? So most of what you showed here, of course, is a statement or data about the United States, and the United States was certainly post-World War II the dominant country and energy-wise leading up to World War II. So, we have to think about other countries now. It adds to the complication. So how do you think about that?
Well, I mean, it's an interesting question. I mean, in a sense, one of the future energy worlds we're talking about is sort of the world that's dominated by lithium and metals, and rare earth metals come into that, but it's more than rare earths. It's sort of the electrified world. We might have a lot of nuclear power in it as well, and in a sense, that's kind of like it's a little bit. You look at countries like France and Sweden that have very little resources in the fossil fuel era, but still have successful economies. So they found ways to survive in the modern economy. Now, if we go to a new world where it's all about who's got the lithium, who's got the rare earths, who's got nuclear, then that could change. It could change. I don't think the US would be greatly impacted because the US is sort of so much size and momentum. It would go on for a long time, just like the way the British economy has maintained itself since it dominated because of coal back, a couple of 100 years ago, right? And it's managed to maintain its wealth through diversifying into other lines of economics. Canada might go down if it doesn't become 51st state beforehand, but it is. I mean, it is sort of the $1 million question or the $1 trillion question. But I probably don't have time to really. Or even actually, I haven't worked it out well enough to give a better answer at this point.
Right. Somebody else is pointing out that yes, person could easily argue China is leading this transition and has made these investments in the metals and the technologies, production wise, that you're talking about. So certainly the place to look. Another question. I think you kind of answered this during your talk, but I'll ask it more specifically again. I guess in the Keynesian era, do you think Keynesianism was successful because of, I guess, just the nature of it, Keynesianism, or it was successful because oil and, as Jamie pointed out, hydropower resources were so abundant that would any economic regime have looked like it was working great during this Keynesian era, as you pointed out?
That is an interesting question. I mean, I know there was investment in hydropower during the Keynesian period and the New Deal, and obviously the roads. And I think if you look at the economy through a sort of a purely conventional economic and financial lens, then the Keynesian policies made sense. The government had to step in because the dominant technologies, the dominant industries, particularly the railroads, had collapsed. Whereas European countries would sort of buy out the railroads and keep them running and made the trains diesel, the nature of the U.S. economic thinking was, well, the trains have just collapsed, the trains have collapsed, right? And then let's build this interstate highway system. So essentially, the government role, the Keynesian role, helped build the architecture of the oil regime. And so, I think there's a lot to be said for the Keynesian lens in a purely economic terms. But the piece that can't be forgotten is that all of that is associated with the oil paradigm. And so the idea is that you need to go back to some kind of Keynesian economics now to do the next energy transition. There may be some truth to that. You probably do need a lot of government interaction, but you got to remember that we're talking about getting off oil, not exploiting an era where oil is so abundant that the US can just adjust the price of oil at will. So I'm kind of arguing it from both sides. I think you need to pay attention to both pieces of that argument.
Right. Well, depending on who you are, you come onto this campus and
Yeah.
have somebody make the argument that the U.S. is in more oil and gas abundance than ever. Of course, in a gross energy standpoint, that's true. What's coming out of the ground.
It is true. Yeah.
Yeah. So we have to understand these links. So with that said, thank you everybody for joining us today. This has been Chris Kennedy, he's professor at University of British Columbia, Victoria. Thanks for joining us on the UT Energy Symposium.
Thanks for having me, Kerry. It's been